Let's start with this presentation of what can be expected from this course. We will create a vehicle rim and its levels of detail. The content shall be divided into 3 chapters. In Chapter 1, we will focus on creating a base model that can be used for both visualization and game industry. We will use a lot of advanced techniques during this process in order to bring our concept design closer to reality. The purpose of creating high-resolution model is to project its geometry on maps or textures. The base model can be used also to create the first level of detail. In Chapter 2, we will optimize the first level of detail and create other levels. In Chapter 3, we will bake the required maps. The preparations for baking textures will be carried on from the first chapter. That will involve adding a light to the scene, adjusting its attributes, inspecting the light behavior, and correcting the geometry if needed. All these preparations must be done with perfection in order to minimize further image editing after the bake. The best optimization of the texture's 2D space is by utilizing its scale to the limit. The baking process requires proper wrapping and UV map optimization. Finally, for this project, we need 6 levels of detail. Each one of them should not exceed these indicative numbers. Keep in mind, the total poly count of the vehicle wheels should not exceed 15,000 triangles for L0. The total poly count of the vehicle with its wheels should not exceed 100,000 triangles. Last but not least, the workflow in this course is authentic, with all procedures and measures provided to help you create the same project, or even better. This will be a very informative and valued course that deserve your attention. Your opinion, questions, and evaluation are always appreciated. It's important to set your system unit correctly to match the project requirements. I am using meters as system unit and generic to remove the unit indicator. Let's start by explaining the technique that we will follow during this course. The current scene contains 2 primitive cylinders, both are at the same scale and location. The 2 cylinders are literally overlapping each other. I have assigned different color to one of them for visual distinguish. The technique that I will use during the modeling involve adding Turbosmooth modifier over low poly cylinder, then gradually shape and manipulate the design in order to dictate the Turbosmooth behavior. However, there are some disadvantages when using this technique. The most frustrating one is the scale mismatch after adding the Turbosmooth modifier. The highlighted cylinder, which has no Turbosmooth, is larger than the tessellated one. The cylinder is still maintaining its logical state, which means we can change the number of sides to 60, just to mimic the tessellation of the other cylinder. Notice, I did not change the radius, or any other attributes. Theoretically, the two cylinders should have identical radius. Clearly, that did not happen. We could try and scale up the tessellated cylinder to match its previous state. At the zoom-in maximum limit, in order to compensate the radius differentiation, we needed to add 0.55% to the scale of the tessellated cylinder. It seems that the two cylinders are now occupying the same space. In fact, they are not. That's the problem of using the scale tool, even with uniform scale and the type-in window. Once an object is scaled inside 3ds Max, it cannot return back to its previous state. The Turbosmooth will smooth the 3D object. During this process, the 3D object is tessellated. In order to smooth the geometry, a relax effect will be always associated with shrinking the 3D object at the XY axis. Unless Autodesk decide otherwise, the final result will not compensate any loss of the 3D object's dimensions. Manual adjustment of the part scale might be required when assembling it to other parts. However, using the scale tool to adjust the scale of the part is not recommended, as the result is not always guaranteed. You need to be aware of these complications while using this workflow inside 3ds Max. Part of being a designer is to have wide imagination, a higher vision to see beyond the surface. In order to have this ability of putting your ideas into a plan of action, I believe that anyone can learn to be a designer with some efforts and adequate training. However, it takes more than that to become a talented one. Before importing or designing, you need to set up the program system unit in respective to the scale of the object that you want to create. In order to design a real-life object, always start with the actual dimensions. The standard method of designing is to have a blueprint of the object. Or, you can recover the measures from the object itself, if possible. The rim in the current scene is closer to the design I have in mind. Let's analyze its geometry. It's a 10-spoke rim for a sedan vehicle. The maximum diameter should be 21 inches. The spokes have some engraved shape. Obviously, this rim was not meant for the game industry. And, in its current condition, it's not useful for anything indeed. This rim was badly designed, even for visualization. While overlapping vertices are acceptable in designing, overlapped faces are not. Trying to fix the geometry of this object is really a bad idea. The best solution, in such case, is to design the whole rim from scratch. Let's create something beautiful. You should always start modeling at the center of the world. I will use this rim as reference. To set the rim to the center of the world correctly, from the pivot menu, select Effect Pivot Only. Reset Pivot to the center of the world. Right-click on the Move tool to open the Transform Type in dialog. 0 the transform values in all axes. Back to the pivot menu, switch to Effect Object Only. Then press Center to pivot. You can correct me if I am wrong. 3ds Max is using the center of volume as reference. In order to align the pivot to the center of the object, and vice versa, the center of mass is calculated by the object vertices. And it's not at the center line of the rim, as you can see. However, the center of volume is at the center of the world. In reality, both the center of mass and the center of volume should be at the central axle of the vehicle wheel. It's crucial to keep the pivot at the center of the rim, as this will prevent any weird animation later inside the game. We shall start a clean design. In the left viewport, switch to the Standard Primitives menu. From the object type, select Cylinder. For the creation method, I use the keyboard entry. Since we are creating 21 inches rim, the radius should be 0.267 meter. For the height, which will represent the width, I use 0.246 meter. For the height segments, I choose 3. And 2 for the cap. The golden number for the sides is 30. When tessellated, it will become 60. And it accepts the division on 2, 3, and 5. Disable the real-world map size. Press the Create button. Apparently, the reference rim is larger than 21 inches. Before we scale it down, let's make sure that the cylinder we just created is at the center of the world. One more thing before we leave the creation panel. In order to compensate the loss of the scale after adding Turbosmooth modifier, I add 1 more millimeter to the radius of the cylinder. At the end of this course, we will discover if my calculations are correct or not. Now, let's scale down the reference rim to match the size of 21 inches. For that, I use the Uniform Scale tool with View as reference for the coordinate system. And of course, the Scale tool is at the center of the object. In the left viewport, scale the object in between the XY axis. That will exclude the Z axis from the scaling operation. And keep the width of the rim unaltered. For precision, let's bring the Transform Type in dialog. Frankly speaking, the Transform Type in dialog, from now on, is going to be our new best friend. Let's redo the scaling operation with precision. Use the screen offset to scale the object in all axes. In the top viewport, reset the value of the x-axis back to 100%. That will exclude the rim width from the scaling operation. After scaling an object, you may want to reset the transform values. And to do so, you need to add Reset XForm modifier from the Modifiers menu, or from the Utilities. As long as the cylinder stays in its logical state, we can change any of its attributes. However, once we add Edit Poly modifier, those values become permanent. We cannot return back and change any of them. The built modifiers in the stack are dependent on each other. 3ds Max do not support history rollback or logical attributes editing in polygons modeling. Only CAD modeling support those features. With our scene being set, let's start modeling. In the left viewport, activate Ignore back faces. Then select all the side polygons. Hold Shift and click the Insert icon on the ribbon. To open the Insert settings, insert a loop at 5 mm from the selection border. Needless to say that we'll also shrink the selection by 5 mm. In the back viewport, select the other side polygons. Insert a loop at 15 mm. Then, delete the selected polygons. Insert a loop to mark the logo, and another one for the mounting area. We do not need this origin loop. Hold Ctrl, then hit Backspace to remove the loop with its vertices. We will add others at specific locations. Select the center loops, then move the selection inward to bend the rim side. After that, use the Swift loop to add 3 more loops, as shown. Now, let's mark the spokes locations by the Cut tool. Switch to vertices mode. Activate Snap to Vertex while using the Cut tool. If you are familiar with other designing packages, what we are doing now is creating a sketch of the reference rim that will become the foundation of our rim shape. After using the cut tool, you should check for isolated or overlapped vertices. At this point, overlapped vertices are not required. Use the weld tool to weld any overlapped vertices. I am using 1 mm as check distance, and our design is clean. One more thing for this designing technique. We need to check for similar shapes to assure the maintaining of the diagonal symmetric. Let's progress in cleaning our design. We do not need these vertices pairs that were created during the cutting process. We could use the weld tool with sufficient weld distance to weld them all. However, here is the trick: we need to weld them in a certain pattern. The spokes vertices must be welded from the inside out. Use target weld to complete the cleaning process. After that, check for similar shapes over the design. If everything were done correctly, you should maintain the diagonal symmetric. Now, let's bevel the side polygons to push them a little bit inward. Set the bevel value to -5 mm. It's time to define the basic shape of the rim. Before we do that, it will be a great idea to add Turbosmooth modifier. For video games, we only use one iteration. For visualization, the iteration's value is 2 or 3 maximum. The more iterations you add, the more memory they require. This is one of those options that you really need to be careful while changing its value. If the number of iterations are higher than the capacity of your machine memory, 3ds Max will be forced to shut down, and you may lose your work progress. If your model is require more than one iteration to look good, you should know that you have exceeded the limit, and your model is not suited for video games industry. It may suit other applications, such as visualization or texturing process. Enable isoline display to hide the tessellation loops. This option will not change any of the Turbosmooth effects on the mesh. It's just a visual mode. We still can work on the submesh while the Turbosmooth modifier is above. On the Edit Poly modifier, use Toggle the End Result button to show the end result on and off. I have already assigned a shortcut for this button, so that I can switch the view between the base and the higher resolution model. Back to our design, select all the side polygons. Insert a loop at 5 mm distance from the selection border. The loop we just added will protect the edge from being consumed by the Turbosmooth modifier. The selected polygons will be used to create the engraved shape of the spokes. We would like to have the base polygon girded a little bit, and to do so, select the middle edge. From Modify Selection, select Similar. in the left viewport, switch to the Scale tool. Use Local as reference for the coordinate system. And the tool in the middle of the selection. If you decide to use the Scale tool gizmo, make sure to use it from the middle, in between the three axes. Here is a bad example of using the Scale tool. In order to maintain the diagonal symmetric when scaling multiple edges, the scale must be applied in between all the three axes. Or, you can use edge constrain and scale in between XY axes. The highlighted selection will be the gaps between the rim spokes. With these polygons selected, use the Insert tool to add a loop at 5 mm. It's very important to create support loops around each group of these polygons before deleting them. Bevel the selection by group with -15 mm in the height and 0 the outline amount. Now, we can take these polygons to a better place. I would like to have the highlighted edges and their similar to be aligned with the back border. But first, it seems that the gizmo is about to disappear. Let's increase its size a little bit. To increase the transform gizmo size, from the preference settings, switch to the gizmo settings. Then increase the transform gizmo size to whatever number suits you. Use uniform scale with view as reference for the coordinate system. To adjust the scale of the selected edges until they match the back border, it's better to add these branches to the selection. For precision, let's bring the transform type in dialog. It's time to define the spoke's engraved shape. To engrave the highlighted polygons, first, insert a loop at 5 mm. Bevel the selection by group with -2 mm in the height and -7 mm in the outline amount. Although, we can increase the bevel height, or in our case, the bevel depth. There will be no enough geometry to support higher value of bevel height at one iteration in the Turbosmooth modifier. Later, we can add more depth by using normal map. We will explain that in the texturing chapter. After the bevel operation, there are some edges left with deformation. To remove those edges, select all vertices. Use the weld tool with 1 mm as weld distance. I would like to have the base of the spokes seamless, with no carving. We could limit the bevel at the base of the spokes by target weld the base inside vertices to the outside. The basic shape of the rim is now complete. We can control the carving depth by using the highlighted polygons. The highlighted polygons are considered to be one of key points that control the shape of the rim. However, the more the depth, the more polygons it will require to maintain good curvature. Currently, I am using 2 iterations in the Turbosmooth modifier. I am going to move the selected polygons by 1 mm on the x-axis. This will add extra depth to the bevel. We will add the bolts and the screws holes. After shaping the inside and the tire mounting area, select the back border of the rim. Switch to the Move tool. Hold Shift while moving on the negative x-axis to extrude the selection. Switch to the Scale tool, set View as Reference, and the tool at the middle of the selection. Use the Transform type in dialog to adjust the scale of the border. until it matches the other side of the rim. Select the inner ring polygons. Detach them as element. Use Turbosmooth to assign a smoothing group to them. At this stage of designing, detaching elements is required where they are needed to preserve edges or borders, shape, and location. Select the outer ring, middle edge loops. Open the Loop tool. In the Edges mode, you can find the Loop tool under Loops on the ribbon. Adjust the distance between the two loops as shown. Switch to the Uniform Scale tool. Use View as reference. And the tool at the middle of the selection. Scale down the selected loops with a transform type in dialog to 96%. Detach the middle ring polygons as element to preserve the loop location. It's time to save and create a clone copy. Right-click on the selected object. From the context menu, choose Clone as Copy. Give the clone a proper name. I will continue working on the cloned rim. Right-click in the viewport. Choose Hide Unselected. Now, let's create the mounting holes. I am going to add a new Edit Poly modifier. We need at least one supportive loop in this area. Use the Swift Loop tool to add the supportive loop. Hold Shift to place the loop at the center of the selection. Another way to place the loop at the center is by connecting the ring edges. Select the polygons in the same formation as shown. Use Insert by Group to insert a loop at 6 mm for each group of the selection. Use the Regularize script to turn each group into a circle. The script works on editable poly geometry. However, on Edit Poly, if I keep pushing my luck, unfortunately, it will break. Here is some frustration while using the Regularize script. When reaching to this point, I have to use editable poly geometry. Use the Rotation tool with local as reference for the coordinate system, and the tool in the middle of the selection to change the rotation of the selection to help the script processing. However, this technique is not always guaranteed. Try to offset the supportive loop away from the center a little bit. Change the inserted amount to 10 mm. Hit relax on the ribbon to relax the selection. The obstacles never end. Rotating one of these circles separately is not really a good idea, especially when trying to keep every edit diagonally symmetric. Now, let's increase the scale of these circles. Use the Scale tool with local as reference, and the tool in the middle of the selection. Although this part of the rim is planar, it's better to use the face constraint while performing the scaling operation. Use the same technique to create the screws holes. Select all the circles we just created. Use Insert by Group to insert 2 mm loop for each. Extrude the selection by -4 cm. It's time to release the reference. Back to our design. Detach the selection to a new element. In this section, we will perform advanced refinement on the rim shape. The intersection lines between the spokes at their extension till the center will be used to break the UV map of the rim. We need to keep these lines unaltered. The spokes heads, which are pointing to the screws holes, I would like to bring them closer towards the center of the rim. In order to do that, we could select the heads polygons. However, I did select the edges. Activate Face Constraint. Scale and uniform the selection. With View as reference, and the tool in the middle of the selection. Rotating the deformed, regularized circle was really a bad idea. Let's fix this fault in more professional way. In the left viewport, select and delete all the deformed polygons. Select one of the correct, regularized areas. Detach the selection as clone. Select the detached object. On the object level, rotate the object. With View as reference, and the tool at the center of the world. Enable Snap to Angle, and change the snap angle to 72 degrees. Attach the object to the rim. Weld the selected elements as shown. Now, we have a clean design. The highlighted polygons will hold the logo of the rim. I would like to bevel them inside the rim. Before we do that, I intend to use these polygons to bend the rim holes. By using the Soft Selection tool, activate Soft Selection from the ribbon. This is how the soft selection looks when activated on editable poly. For better visualization, let's add Edit Poly modifier, then activate the soft selection. Lower the fallout radius to 100 centimeters. The areas in gray are frozen and will not be affected by the soft selection. The areas in dark blue color are the limit of the soft selection effect. They will be subjected to the lowest effect by the soft selection. As we move closer towards the center, you can see the color switches to hot colors until it reaches orange, which represent the areas that will be affected the most. They also represent the center of the fallout. If we grow the polygon selection, more areas will be added to the center of the fallout. I am not going to do that. The current selection is perfect. With 100 centimeters fallout radius, it covers the areas that we want to bend the most. If we increase the fallout radius to 150 centimeters, the effect of the soft selection will grow stronger, and it will extend at an account of the blue areas. Now, let's use the Move tool. Lower the fallout radius to 100 centimeters. And that's exactly what we are looking for. Now, let's move the selection on the x-axis in order to create the bevel effect. For precision, we can use the transform type in dialog. Before moving the selection, it was preferable to add a supportive loop first. Adding a supportive loop at the current location is not really a good idea. We can return back and add the supportive loop at proper location. Or, we could use the Move tool to bring the current loop to the desired location. This part might seem tedious, but it's for educational purposes. Whenever you need to create holes or bevel, you must use supportive loop first. The loop must be at the same level of its surrounding. This is why it is called supportive loop. Also, you must avoid having any star vertex on a border edge or main loop. The supportive loops can be also added to create and control chamfering effect, as shown. The soft selection did affect some background surfaces, which are required to be planar. Select all the background vertices of the bended area. Align them on the Z-axis. If we take a closer look at this vertex and its similar, it would be better if we could shift them towards the screws holes. In order to do this editing in diagonal symmetric, select the loop polygons around the screws holes. Press Insert to insert a supportive loop inside each group. Now, select the edge which connect the vertex and its similar. Collapse the selection. Remove the remaining unnecessary edges of the supportive loops to clean up the geometry. We have come to a crossroads where everything is connected, and they need to be setted correctly. Before jumping into the next step, there are some questions that demand answers. How the light will react over the current geometry? What is the correct settings for the light? In this section, we will examine the light behavior over the geometry. Find the best settings for the light we add, and correct the geometry if needed, as an early preparations for the bake-to-texture process. In order to minimize further image editing after the bake, let's add a background to the rim. Switch to the left viewport. Create a plane with 2 by 2 meters dimensions. We can move the plane to be completely at the back of the rim. However, it will not matter at all. Later, for the baking process, I will use standard Omni light. Let's add one to the scene. Change the multiplier value to 0.9. Insert the light on the x-axis at -2 meters. Use the transform type in dialog to adjust the light location. When adding a light to the scene, the default scene lights will be automatically disabled. Let's do a quick rendering. I am using the default scanline renderer for quick rendering. We want to remove any black lines or areas on the rendered image. There are many reasons that can cause these black lines. One of them is the geometry itself. Let's inspect the rim's geometry. This edge is consumed by the Turbosmooth modifier. We can either add a supportive loop for this edge, or we can simply detach the background outer ring polygons loop. The second reason is the light settings. Let's bring the Omni light closer to the rim. Set the light location to be at -40 cm on the x-axis. Let's do a quick rendering. These black lines are just shadows cast by the light. We do not need any shadows to be cast by the light. For that, in the light settings, change the value of the shadow density to 0. In order to remove the black lines at the gaps borders, select all the gaps borders. Use the uniform scale with local as reference, and the tool at the center of the selection. Scale down the borders with the transform type in dialog to 80%. Let's do a quick rendering. One of the most important settings of the light is the light coverage. Bad light coverage can cause dark lines or dark areas over the geometry. The Omni light creates a circle or a conical shape from its center, hypothetically speaking. Obviously, this imaginary light shape is not wide enough to cover the peripheral parts of the rim. Unfortunately, we do not have any indicator for how wide this circle is inside the viewport. When using the Omni light, accept the scale transform values. In the left viewport, with view as reference and the tool at the center of the world, scale up the light on the XY axis as shown. Now, let's fix the black circles around the mounting holes. Detach the highlighted polygons to a new object. Later, we will use them to create the rim bolts. Select the borders of the bolts holes. Scale them down with local as reference, and the scale tool at the middle of the selection. For precision, use the transform type in dialog. remove the inside supportive loops. We can control the gradient color effect around the holes by adding another supportive loop, as shown. The outside supportive loops will be consumed by the Turbosmooth modifier, while the inside loops will remain in their places. And keep balanced tension around the edge loops of the holes, thus controlling the gradient color effect, or to be precisely, the light effect over the surface. I would like to weld the ring loop, which is surrounding the rim logo, to the rim main element, so that we can chamfer the in-between edge with supportive loops, as shown. At this point, we need to evaluate the overall shape of the rim in order to perform the final refinement on its shape. I am going to increase the depth of the spokes by moving the gaps borders on the x-axis, as shown. Let me remind you, this is only one iteration in the Turbosmooth modifier. And the current poly count is way too high for the game standards. With the Turbosmooth modifier added to the mesh, the poly count is in triangles. We can confirm it by showing the triangles count on the statistics. We need to bring down this poly count to meet the game standards. That will be quite challenging for the optimization process in the next chapter. However, at one iteration, we could not increase the spokes beveling because there are no enough polygons to support that kind of curvature. For visualization standards, the one iteration is considered to be low poly count. Thus, we do not ask too much from the geometry at this low level of tessellation. Now, let's create the bolts of the rim. we need only 6 sides to create hexagon bolts. Regularize the selected borders. We will not create any screws for this rim. Select all polygons. Use Insert by Group to insert a loop, add 4 mm for each group of the selection. Extrude the selection by 3 cm. Detach the selection to a new element. I will need the following edit only for the bake-to-texture process. In order to cast some shadows over the bolts' heads, use Insert by Group to insert a loop, add 2 mm. Move the selection on the negative x-axis as shown. Select all borders of the bolts holes. Scale them down to remove any gap between them and the bolts. Now, we need to add the holes limit or the background. Interesting. Maybe later. From Shapes, create N-gon with 5 sides and 9 cm radius. Now we have one pentagon to cover them all. To convert the N-gon to polygons, add Edit Poly modifier. Rotate the selection 18° counterclockwise. Manually or automatically tessellate the pentagon. We will need 2 base models. One with 2 or 3 iterations in the Turbosmooth modifier. That will be used to bake the required maps. I am going to add V, for visualization, to its name. The other one, with one iteration. That will be optimized in the next chapter. In order to create the first level of detail, I am going to add GR, for game ready, to its name. For the visualization base model, we can increase the spokes beveling. We can also add more details on the mounting area. These vertices are one of the key points that control the geometry. Let's add these details in more professional way. Before moving these vertices, we need to support the area around them with supportive loops. However, putting details on the UV map separation lines is not recommended. These details will scatter the light and create gradient effect over the baked maps. After baking the required maps, further image editing will be required. In order to overcome the gradient effect, we will fully uncover that in the texturing chapter. The following is the final editing we shall do in this chapter. I am going to do it on a new Edit Poly modifier. There are other key points that control the geometry. For instance, the selected edges, which can control the width of the spokes. If you do like this editing, you can transfer it to the other clone of the rim. Simply copy the Edit Poly modifier and paste it on the other clone. from the unlimited possibilities of the editing that we can do. These are the two possibilities that I chose to present in this tutorial. Currently, we are using 2 iterations, and the model is looking spectacular. By now, we know that we are on the right approach. Later, we will use one of these models to bake the required maps. The odds are unlimited. Which one should we go with? Let me know in the comments.